Good morning. This is going to be Objective 5. We are going to solve quadratics by factoring and by using the quadratic formula. So this should be Algebra 2, so hopefully it will go pretty quick. So let's talk about the quadratic formula. Go ahead and sing it for you one time. Here we go. Ready? Me. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And we know that this works when it's in the correct form. When ax squared plus bx plus c is equal to 0. So if you're going to set up the quadratic formula, you have to set it equal to 0 first. A is going to become the coefficient that's in front of the x squared. B is going to be the coefficient that is in front of the x. And C is going to be the constant or the number that's by itself. Okay? So I do like to talk about the discriminant. Okay? The discriminant is what is actually under the radical. Okay? If you look at the quadratic formula, x equals negative b root of b squared minus 4ac. That's what goes under the radical. Well, the discriminant, I like to split the quadratic formula up into kind of like two parts. I like to work the discriminant first, and then I like to go and put it all into the formula, because the discriminant is going to give me a really good idea of what kind of answer I'm looking at. Okay, we know if the discriminant, what's under the radical, is a positive. Like, for example, if I have, give me a positive number. If I have the square root of 9, what's the square root of 9? We know the square root of 9 is plus or minus 3. So we know that our answer is 3 a real number, or positive 3, negative 3. Are those real numbers? Yes. 3 is a real number, so I know that I'm going to have two real solutions. So I know if the discriminant is positive, I'm going to put a little equal, that I'm going to have two real solutions. Okay. Oops. Let's go back before it's acting weird. Solutions. There we go. Okay. If the discriminant is a negative, like for example, give me an example. Let's say the square root of negative 9. Well, we know the square root of negative 9, the square root of a negative, that's non-real. That's imaginary. That's going to be plus or minus 3i. And so that's going to give me an inclination that if this number, if the b squared minus 4ac is a negative, that's going to give me two imaginary solutions. Because if you take the square root of a negative, you'll get an I. You'll get an imaginary number. Okay, and there's going to be two of them because one's plus, one's minus. We know if the discriminant is equal to 0, so the square root of 0, it's just going to be 0. And it's plus or minus 0. The idea here, though, is if I add 0 or if I subtract 0, it's going to be the same answer. So how many answers will I have? I will just have one, and it will be a real solution. Okay? It's just if I add 0 or subtract 0, it's going to be the same answer either way. So I'm only going to have one real solution. Solution, singular. Okay? So let's go ahead and put this into action. And what I'm going to do here is I'm going to kind of review the factoring. So I'm going to solve it by factoring, and then we're going to solve it by using the formula. That way you can see you get the same answer twice. So let's take factoring first. Okay, let's look at it and say, first of all, it's got to be set equal to 0. Is it set equal to 0? Yes. So let's try to factor this. I could factor this into x, and plus 4, and plus 5, and that's equal to 0. Now, I'm not finished. Just because you factor it does not mean the answer is not 4 and 5. I promise you. Okay? We know blank times blank equals 0. Well, if that happens, what would have to be in one of those blanks? In order to get 0, you've got to multiply by 0. So either this blank, it wouldn't matter what's there. 0 times anything would equal 0, or you could do the reverse. This blank could be 0. Well, my thought is this. Do you have two things being multiplied together to equal 0? Yes, you do. Blank times blank equals 0. So in order for us to get 0 right there, this guy has to be equal to 0, or this one needs to be equal to 0. And so my question is what would x be to make that 0? Well, if you solved it and moved this over, x would be equal to -4 and -5. So the answer is going to be -4 and -5. Okay? So that's how you solve this by factoring. Now I want to look at it by using the formula. And so what you may want to do on your notes is kind of make a column, like one column, this is how we do it by factoring, and then the other column, this is how we do it with the formula. Okay? So first things first, let's write our formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. And so let's define a and b and c. A is the number in front of the x squared, b is the number in front of the x, and c is the number that's by itself, it's the constant. Okay, and so again, I like to just take that discriminant. Let's just go over here to the side and just work the discriminant. Okay, so I'm going to plug in 9 squared minus 4 times 1 times 20. And you can put this all in your calculator all at once. 9 squared minus 4 times 1 times 20. I believe you should get 1. Or if you work it by hand, this would be 81. Then you multiply minus 80, so you're going to get 1. Okay? And we know that the square root of 1 is just going to be plus or minus 1. So now we can go back up and just take this and plug it in for that, because we know that that's what that's equal to. And so what do we know about our answers? Is this number positive? What's under the discriminant? The discriminant is positive. We're going to have two real solutions. Okay? So -b, so that's going to be the opposite of b, which would be -9, plus or minus, we know all this is equal to 1 divided by 2 times a, or just 2 times 1, which would be 2. And then you can actually work this out. -9 plus 1 divided by 2. So that would be -8 divided by 2, which would be -4. That's one answer. And then the other one would be -9 minus 1 divided by 2. So that's going to be -10 divided by 2, which would be -5. And that's what we got a few minutes ago. We got -4 and -5. So two different ways to do the same thing. Okay? Now I know what you're thinking. Some people say, why in the world would, like, you know, if you could just factor it's going to be a lot quicker. Why don't you just factor? Well, I agree. If it's factorable, then I would solve it by factoring. But not every answer is factorable. So let's keep going. Let's take a look at this. Is this one factorable? I think it is. So this could be a and a. I think you could do -9 and -2. Nope. Hold that thought. That's not going to work. 6 and 3. Yeah, I don't think this one is going to be factorable because you can't get a positive 11 with a -18. So, okay, so if you make columns on your notes, what would you say on the factoring side? I would say this one, you can't do this one by factoring. This one is not factorable. So let's try doing it by the formula. So factoring doesn't work for every single problem. Let's do this one by the formula. Okay, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's define a, b, and c. A would be 1, b would be 11, and c would be negative 18. All right, let's work our discriminant first. So b squared minus 4ac. So 11 squared minus 4 times 1 times negative 18. Okay, so I think when you put that into your calculator, I came up with 193. Okay, now that is a positive number, which means we're going to get two real solutions, but I think they're going to end up being, like, we know the square root of 193 is square root of 193. They're not going to be whole numbers. They're not going to be integers. Okay? They're not going to be fractions. These are going to actually be irrational numbers, because when you put in the square root of 193, you're going to get a non-terminating, non-repeating decimal. Okay? And you can try to simplify 193 and try to break it down, but I don't think it's going to be able to be simplified. So, like, if you could simplify that, I don't know, into 2 times the square root of 7, then, you know, factor tree it down and simplify it. But I don't think this one can, so we're just going to leave it square root of 193. Okay, so let's go plug into our formula. Negative b is going to be the opposite of b, which would be negative 11, plus or minus, let's plug this in, the square root of 193, all divided by 2 times 1, or 2. And I think at this point in time, you would just leave it like this. Nothing can be simplified. You can't add negative 11 with the square root of 193. I mean, you could. You have to get a decimal and round it. So most of the time, if it turns out to be irrational, you just make sure the square root is simplified as far as it can go, and you just leave it in square root form. So, and that is two answers. You've got negative 11 plus the square root of 193 over 2, and then you've got negative 11 minus the square root of 193 over 2. So do you understand? Like, factoring works great if it's factorable, but I don't think every single one is factorable. So what I'd like for you to do is go ahead and take a look at this one. First thing you need to do is you need to set it equal to 0. My question is where would you put the 7 in? We're going to put the 7 in standard form, so it's going to go in the middle. So n squared minus 7n, because when he comes across the equals, he turns to a minus 120. And I want you to hit the pause button. I want you to see, like, try. Is this one factorable? I think it actually is factorable. And then try it by the formula and see if you get the same answer twice. Okay, so I think if I factored this one, we do n and n, and I think you could do minus 15 and plus 8. Negative 15 times 8 is negative 120, and when you add negative 15 and 8, you get negative 7. So this one is factorable. Now, we're not finished. Remember, blank times blank equals 0. So n minus 15 would equal 0. What would n be? N would be positive 15. Or n plus 8 would have to equal 0, which means n would be negative 8. So I think your answers are going to be negative 8 and 15. So just kind of remember, we know that the factors, here's your factors, are opposite from the actual solution. Okay, the solution are opposite from the factors. So let's see if we get 15 and negative 8 if we use the formula. Oops. Okay. So you still got to set it equal to 0. You still got to put it in standard form. So in the correct order, degree of 2, degree of 1, degree of 0. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So a, b, c. A is equal to 1, b is equal to negative 7, c is equal to negative 120. Let's do our discriminant first. So over here on the side, b squared minus 4ac, negative 7 minus 4 times 1 times negative 20. So I'm going to tell you right now, oops, this is squared. If you put it in the calculator just like this, it will not give you the right answer. We're missing something. You have to make sure that you put parentheses around everything that you plug in. Notice the square goes on the outside. That is like my one tip for you, because you will not get the right discriminant if you do not use your parentheses correctly. So let's put this in. I got 529. And if we take the square root of 529, we know that that's going to equal to plus or minus 23. Okay. So, because that could be, I always check to make sure it's perfect. And then if it's not perfect, I check to see if I can factor tree it or simplify it. And if I can't simplify it, then I'll leave it as a square root. But this one was perfect, so I'm going to plug this into the formula. So the opposite of b. Now, when I plug in negative, and then I'm going to plug in a negative 7, that's going to be 7, positive 7, plus or minus 23 divided by 2 times 1 or 2. I can keep going with this one because you can actually add 7 and 23. So you could do 7 plus 23. My board's not wanting to write. Oops. Let's see if we can fix this. There we go. Divided by 2. So 7 plus 23 is going to end up being 30 divided by 2, which would be 15. And I think we got that answer. Then you can do 7 minus 23 divided by 2. 7 minus 23 is going to end up being negative 14. Negative 16. Sorry about that. Divided by 2, which is going to be negative 8. And that's what we ended up with before. So our answers are negative 8 and positive 15. Okay. Just a couple more. So what I'm going to let you do is you can hit pause and you can try to factor it and then do the formula. And then I'll let you choose which way you're going to tackle it. Okay. So I'm going to go ahead and start. I'm going to start with the formula. Okay. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's define a, b, and c. A is 4, b is negative 24, and c is 35. Okay, b squared minus 4ac all over 2a, but I'm not going to do that part first. All right, let's plug in. 4 squared minus 4. Miss Corns. Sorry. I'm losing my brain. Let's try again. Erase. There we go. Okay, let's put in negative 24. I plugged in A, not B. So B is negative 24 squared minus 4 times 4 is A times 35 is C. Okay, so you can put this directly into your calculator. Make sure you include parentheses. Minus 4 times 4 times 35. And I ended up with 16. And so we know the square root of 16 is plus or minus 4. So this one was probably factorable, but so I hope you were able to get it by factoring, but I'm doing it the method of the formula. So the opposite of negative 24 is going to be positive 24 plus or minus 4 divided by 2 times a. 2 times 4 would be 8. So then you can actually work it out. 24 plus 4 divided by 8. So that's going to be 28 over 8, which would reduce to 7 over 2, I believe. And then 24 minus 4 over 8 is going to end up being 20 over 8, which would reduce to 5 over 2. So I believe your two answers are going to end up being 7 halves and 5 halves. Okay? All right, let's try this one. And this will probably be where we stop. So let's try this one and then we'll be finished. Okay? So first we got to set it equal to 0. So let's move this over. X squared minus 2x plus 5 is equal to 0. And if you're looking at it, I don't think this one's factorable because there's nothing that multiplies to be 5 that can add or subtract to be negative 2. So I don't think you can do this one, I think, by factoring, but let's try by the formula. Okay, the formula is a good way. The formula will get you every answer every single time. Okay, so if you're going to put a lot of stock into one particular method, I would say go formula. Okay, until tomorrow's lesson when we complete the square. And then you can choose. Completing the square and the formula, they both will get you every lesson every time. Okay, factoring is really easy, but factoring doesn't work all the time. When binomials and trinomials are not factorable, then you cannot solve by that method. You have to use a different method. Okay, so x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So let's look at b squared minus 4ac. So negative 2 squared. And I guess I should define a, b, and c. Getting ahead of myself. A is 1, b is negative 2, and c is 5. So minus 4 times 1 times 5. So I believe when you solve this, you're going to end up with negative 16. Okay, so what do we know about when this number's negative? If I take the square root of it, when you take the square root of it, you're going to end up with an imaginary number. So we know that this is going to have two imaginary solutions, okay? Because when a negative, the definition says when a negative comes out of the radical, it comes out as an I. So this is going to be plus or minus 4i, okay? So negative b is going to be 2, positive 2, because it's the opposite of b, plus or minus 4i divided by 2. Now, the question is, are you finished? No, you are not finished because something can simplify. These are things on the outside. So I would say there's a couple different ways you could do this. You could simplify like this, and you could simplify like this. That's one way. So 2 divided by 2 would equal 1, plus or minus 4 divided by 2 would equal 2i. That's one way to do it. Okay. The other way you can do it, if you have me in Algebra 2, I kind of looked at a different way to do it. And the other way to do it is by factoring. Like you could factor out a 2 up top, and you would be left with 1 plus or minus 2i. And now that it's on the outside, the 2's can simplify, and you're left with 1 plus 2i. So that's another way. And you just pick your method that you would like to choose. So I'm going to stop right there and be prepared for class tomorrow. We're going to practice.